Okay, so again, welcome to my channel. Today we are going to study about the cardiac cycle. This cardiac cycle is very important since it is asked. There are many questions that are asked from the cardiac cycle in NEET and even in class 11th and in many Olympiads and everything. So today I'm going to teach the cardiac cycle from my own notes that I made during my Akash module, and this also goes hand in hand with MBBS standard books like I won't say standard books, but yes, MBBS books like Sembolingam and all. So this is a complete physiological knowledge that you need that you require for cardiac cycle. Okay, so let's start with the cardiac cycle. So it states that what is a cardiac cycle? Cardiac cycle is the events that occur from beginning of one heartbeat to the beginning of next is called a cardiac cycle. So cardiac cycle is the from one heartbeat, from the starting of one to another heartbeat is complete is called a cardiac cycle. Now what is the duration of cardiac cycle? The duration of cardiac cycle is 0.8 seconds. What is the duration? 0.8 seconds per beat. Now the question is, how did we arrive to 0.8 seconds? Now you can see there is general mathematics. If 72 beats, we know in a minute there are 72 beats, take about 60 seconds, then one beat would take about 60 by 72. That comes out to be 0.8 seconds per beat. Next, we go forward. What is this? Now, what is this? This is a typical ECG. Pardon. This is a typical ECG, not ESG. This is a P wave. This is a Q, R, S, and T wave. Right. P wave stands for atrial depolarization. QRS stands for ventricular depolarization, and T wave stands for the ventricular repolarization. Okay. Now let's see here the ventricular systole part. Ventricular systole is contraction plus ejection. That means when the ventricles would contract, the let's draw a diagram of the heart. Let's draw a diagram of heart. So suppose this is a diagram of heart. Okay, that's a very basic diagram. There's the right ventricle, left ventricle, left atrium, and there's the right atrium. Right. So when the ventricular systole means ventricular contraction. So there is contraction plus ejection of blood. That means blood is filled here. Blood is already filled, and when the ventricles would contract, that is, then the blood here would come out from this vessel, right? From this it will come out. That is the that is from the pulmonary trunk. It would come out, right? This is the ventricular contraction plus ejection. So when that means not only right ventricle, I'm just saying of the right ventricle, and from the left ventricle also, they all contract at the same time. So when the right ventricles contract, it come out from the pulmonary trunk to the right and left lungs. Okay. Next is the ventricular diastole. Ventricular diastole means relaxation plus filling. That is relaxation plus filling. Relaxation of the ventricular musculature and filling of blood. Atrial systole implies atrial contraction plus ventricular filling. When there is atrial systole, when there is systole of the atria, when the when the atria is contracting, that means blood in the atria is pushed into the ventricles. When the atria is contracting, the blood in the atria is pushed into the ventricles. That is what it is saying, that when atrial systole, there is atrial contraction plus ventricular filling, and when there is this should be atrial diastole. This should be atrial diastole, and when there is atrial diastole, there is atrial relaxation plus atrial filling. Okay. Now we'll come to this is a typical diagram of the this is a typical diagram that this diagram you need to make if it is asked in exams for CBSE level students and for NEET. This diagram may come in NEET. That is, there are less chances because since it is not there in NCERT, it won't come. But still, if you make a diagram in school levels, this is the diagram that you need to make. Okay, but before coming to this diagram, let us see what is. We'll come to it. But before that, let's read the theory first. Yeah. So the ventricular systole is about 0.3 seconds. The ventricular systole is about 0.3 seconds. Ventricular systole, that means the total ventricular contraction is about 0.3 seconds. Here, yes. So first is the isovolumetric contraction. That means both the that means iso volume here. Let's break it down. Let's break it down. So iso means same, volumetric means same volume. So keeping that means isovolumetric means same volume but different tension. Isovolumetric means same volume but different tension. I will come to that. This is not required, at least for UG level, but it's okay. So all valves closed during the contraction. What it's saying that during isovolumetric contraction, all the valves are closed during contraction. Yes. Okay. What's the issue with this? So during isovolumetric contraction, that means, again, let's draw the heart. This is the heart. So what is the isovolumetric contraction saying? The isovolumetric contraction is saying that when the ventricles would first contract, all the valves, this is the tricuspid valve, bicuspid valve, closed. Valves are closed. Then the semilunar valves are also closed. The semilunar valves are also closed. Okay, let me draw the semilunar valves. The semilunar valves are also closed, right? The semilunar valves are also closed. This is the aorta that will go aorta. The aorta, this is also closed. This is also closed. So all the valves are closed in the isovolumetric contraction. During this contraction, all the volumes are closed. All the valves are closed. Contraction of both the ventricles. Both the ventricles contract simultaneously. That is, even this right ventricle contracts, even this left ventricle contracts simultaneously. Volume constant, pressure increases. That is what I tell. The tension increases and the tension and pressure. But different pressure and tension increases. So pressure increases and tension also increases. Volume is constant. See, the volume remains constant. Why would the volume remain constant? Yes, it's definitely the volume would remain constant because the blood is not flowing. The blood cannot come out because all the valves are closed at this moment now. Because all the valves are closed, so blood cannot come out. Blood is still there. Blood is still here. Blood cannot come out. So volume remains constant, but the pressure changes because we are applying some contraction. That is why the pressure would change. And after 0.2 to 0.3 seconds, sufficient pressure is generated. That is 80 millimeter Hg. What happens? The semilunar valves open. What are the semilunar valves? The semilunar valves, again, let's draw the heart. These are the semilunar valves. These are the what are semilunar? These are the, that means the these are the semilunar valves. The semilunar valves open. After applying sufficient pressure, the semilunar valves open. Aortic and pulmonary valve. That is the aortic and pulmonary valve. That is pulmonary trunk. This is what we know. This is the pulmonary trunk, and this is the aorta. Right. See, knowing the different vessels of the heart and the different valves of the heart is necessary for understanding this cardiac cycle. I'm taking in consideration that you all know that, right? That since keeping that in mind, I'm teaching. So the semilunar valves open after 0.2 to 0.3 seconds. That is after applying sufficient pressure. The aortic and pulmonary valves open. Okay. Next, come to the next phase. So this is the first phase of isovolumetric contraction. That is here. This is the isovolumetric contraction. What happens? Closure of AV valves. First of all, there is closure of AV valves. First of all, there is closure of the atrioventricular valves, and here this part is the isovolumetric contraction. This part is the isovolumetric contraction part. Okay. This is the ventricular systole. That is actually at 0.27 seconds, but we approximate it as 0.3 seconds. Next is the rapid ejection. Rapid ejection is the two-thirds of the volume of blood is ejected. In rapid ejection, see in the isovolumetric contraction, all the valves are closed. At the last stage, semilunar valves open. But still, then in the isovolumetric contraction part, blood is not ejected out. But in the rapid ejection part, two-thirds of the blood is ejected out. Two-thirds of the blood is ejected. Two-thirds of the blood is ejected in the rapid ejection part, and in slow ejection, see, this is the rapid ejection part. This part is the rapid ejection. This is the rapid ejection part. Rapid ejection. And in slow ejection part, remaining one-third of the volume of the blood is ejected. And in the slow volume part and the slow ejection part, the remaining one-third of the volume of the blood is ejected. Here the remaining one-third of the volume of the blood is ejected. So what happens? First, there is there is very strong contraction, but till then all the AV valves are closed, and no blood is, that is isovolumetric relaxation, no sorry isovolumetric contraction, that is no blood is ejected out. At the last stage of the isovolumetric contraction, what happens at the last stage of the isovolumetric contraction, what happens is that the aortic and pulmonary valves open, right? And in the rapid ejection part, two-thirds of the volume of the blood is ejected, and in the slow ejection part, one-third of the volume of the blood is ejected. Okay, so what does it state? Blood that remains in ventricles after ejection contribute to the ESV. What is ESV? Blood that remains in ventricles after ejection. After ejection, that remains is contributes to ESV. What is ESV? Is the end systolic volume, that is about 50 ml. 50 ml of blood remains in the ventricles even after contraction. After contraction, 50 ml of blood remains in the ventricles. That is known as the end systolic volume. End systolic volume. Stroke volume is 70 ml. That is the amount of blood. What stroke volume? Amount of blood pumped out by ventricles in each cardiac cycle is the stroke volume. What is stroke volume? Amount of blood pumped by ventricles in each cycle is the stroke volume, right? Okay, next we come to the ventricular diastole part. The ventricular diastole, as we have seen, the total ventricular systole consists of how much time? The ventricular systole consists of 0, it is actually 0.27 seconds. We approximate it as 0.3. And in the ventricular diastole part, the ventricular diastole is 0.53 seconds. It is how much? 0.53 seconds. It is divided into 5 phases. So what we have learned till now is that the ventricular systole is divided into 3 phases. Ventricular systole divided into 3 phases: isovolumetric contraction, then is the rapid ejection, and then is the slow ejection, right? All these. And the ventricular diastole is divided into 5 phases. What are they? First is the protodiastole. What happens? Elevated pressure in distended large arteries. Elevated pressure in the distended large arteries, that is aorta plus pulmonary trunk, pushes blood back towards the ventricle. Semilunar valve, that is aortic and pulmonary valves, close. So what happens in protodiastole is that now, as the blood, let's see here, blood in the pulmonary trunk, I'm only drawing the pulmonary trunk and the aorta. Blood in the pulmonary trunk and aorta is high, right? Blood in the pulmonary trunk and aorta is high. So this is the aorta. What happens? The blood in the pulmonary trunk and protodiastole, elevated pressure in the distended large arteries. What are the distended large arteries? The pulmonary trunk and the aorta are the distended large arteries. Pushes blood back towards ventricle. They push the blood back towards the ventricle. Again towards the ventricle. What happens to prevent that from happening? The semilunar valves, that is the aortic and pulmonary valve, close. So there's something to be marked here, that the semilunar and the aortic valves close in the which stage? That is the protodiastole, semilunar, and the aortic valve close. The semilunar valves close. Next we'll come to the isovolumetric relaxation. What happens is that here all the valves are closed in isovolumetric relaxation. Right? Relaxation of ventricles relax. Ventricular pressure, volume is constant, pressure decreases. Now since there is no blood and since they are not contracting, so the pressure falls. All the valves are closed. Till now all the valves are closed, right? The semilunar valves, the atrioventricular valves, these valves are also closed. Now 0.3 to 0.6 seconds, pressure is deficient in ventricles. Blood fills in ventricles. To the aorta to the ventricle, high pressure to low pressure. See, blood moves out through this, and let me change here. So blood moves out through this aorta and the pulmonary trunk, also to the this and this. They come again from the left ventricle and from the left and right atrium. They enter the atria. This is the atria. Now what happens is that as the pressure is low inside the ventricles, blood comes inside the In the isovolumetric relaxation part, pressure deficient in ventricles, blood fills in ventricles, atria to ventricles, blood is getting filled. In the rapid filling phase, maximum blood filling occurs, that is first one third time of the diastole. Rapid filling occurs, maximum blood filling, 80% of blood filling occurs in rapid filling and the slow filling phase. In the rapid filling, first one third time of the diastole is the rapid filling phase. Whose diastole? Diastole is of ventricle, not the atria. Diastole is of ventricles. This is the ventricular diastole. Look. This is the ventricular diastole. Isovolumetric relaxation start. Isovolumetric relaxation. Rapid. This isovolumetric relaxation. This is the rapid filling phase. This entire is the rapid filling phase, slow filling phase, and this is the filling due to atrial contraction. We'll see that. Rapid filling phase is maximum blood filling. First one third of the time of diastole. 80% blood fills in the rapid filling phase and slow filling phase. Small amount of rapid fill. Small amount of. Wait, what happened? Yeah. Here, small amount of blood filled. Second two-third time of the diastole, also known as diastasis. The slow filling phase, also known as the diastasis. Next, last is the atrial contraction blood fill, also known as the atrial kick. Third one third time of the diastole. Remaining 20% of the blood is filled here. So 80% is filled in the rapid filling phase and slow filling phase, and the last atrial blood fill, that is the atrial contraction of the blood fill. Last rapid filling phase is the atrial kick. It's third one third of the time diastole. It is 20% of blood. 20% blood is filled. Final amount of blood that comes in ventricles after completion of ventricular diastole is 120 ml. And so, what is end diastolic volume? End diastolic volume is how much? 120 ml. End systolic volume is how much? You have seen end systolic volume that is remaining in the lungs is 50 ml, right? 120 and 50 ml is the end systolic volume, and diastolic volume is the end diastolic volume is 120 ml. End diastolic volume, and here we have seen the end systolic volume. See, end systolic volume is 50 ml. Now we'll come to the heart sounds. The heart sounds are they are heard with the help of a phonocardiogram. They are measured, or they are heard by a phonocardiogram. Yes, they are heard by a phonocardiogram. Now, first heart sound S1, closure of AV valves, closure of the atrioventricular valves. Where does it occur? In the isovolumetric contraction. What happens here? We have studied. Where does it occur? See, isovolumetric contraction, all the valves closed during contraction. Here, all the valves means what? Even AV valves are also closed. No? Because if the AV valves are not closed, if the AV valves are not closed, then if these are open, then what will happen? If the ventricles contract, the blood will move again to the atria. We don't want this. We want to prevent this. So, to prevent this, what happens is that AV valves close during the isovolumetric contraction. Second heart sound S2. Here, mitral and tricuspid. It is low pitch, high time. It is low pitch. That means the pitch is low. Pitch is low. It is not very shrill. Pitch is low. And second heart sound is S2, closure of the SL valves, closure of the seminal valves, aortic and pulmonary valves. Is the when does it occur? Isovolumetric relaxation, because the pressure in the distended large arteries, the pulmonary trunk and aorta, they force this seminal valves to close. High pitch, low time. They have high pitch. See, the pitch is very high. It is very shrill, but time is low. The time is low. It is dub. It is lub. So lub is the first, dub is second. Then third heart sound, or S3. It is the third phase of diastole, that is rapid filling phase. Third phase of rapid filling phase. It is physiological heart sound. Third heart sound, rapid filling phase. In this it occurs. Rapid filling phase. In this is occurs. This here the third heart sound. S3 is heard. No, S3 is heard. It is in which condition is heard? It is heard in exercise, in children, and in pregnancy. So in pregnancy, in children, and exercise, we hear the third heart sound. That is the third phase of diastole. And the fourth heart sound, or S4, it is the forceful atrial contraction. Atrial contribution is more than when the atrial contribution. See, we have learned here that atrial kick is how much? 20%. But if due to some pathological or some idiopathic conditions, what is pathological? Due to some deformity, some anomaly, some atrial fibrillation, or any kind of first degree myocardial infarction, second degree heart block, any reasoning, any cause, any underlying cause, then what if the atrial contribution is more than 20% ventricular filling, then we have fourth heart sound. That is the pathological condition. Right? That is a pathological condition when the atrial filling is more than 20%. Okay. Now, what is ventricular stiffness? These are not required. These are actually not required. These are very irrelevant, they're not required. So this we can see, this is the mm, this is the point A, point B, point C, and point D, right? So point A, 50 ml ESV, end systolic volume. Before that, let's see here. At A, what happens? AV valves open. At A, AV valves open. The atrioventricular valves, the atrioventricular valves open. That is the atrioventricular valves open. They open in, here we can see the AV valves. They open. So these open here, na. During the isovoluntary relaxation, the AV valves open here. So AV valves open. Then at B, mitral valves are closed. These are not required actually. Not required. This is okay. Leave it. This is not required. Okay, with this this stroke volume you can see, and this stroke volume I already ejection fraction is stroke volume by EDV into 100 by the end diastolic volume into 100, and cardiac output is stroke volume into heart rate, that is about approximately 5 liters. So that's it for the cardiac cycle.